Thank you so much, sir. Ladies and gentlemen, I'd request you all to please welcome the chairman and the co-chairman of the first technical session of the International Technical Seminar held in Guwahati today. I now hereby request all the presenters for the technical session 1 to take their seats on the stage.
Shri Naveen Chopra, Principal Chief Engineer, Northern Railways. Shri Ashish Bansal, Chief Engineer, Track Machines, Northern Railway. Shri Neeraj Kumar, Group General Manager, DFCCIL. Praveen Kumar, Group Manager, Procurement, WDFC. Shri M.M. Agarwal, former Chief Engineer, Railways and former Executive Director, IPWE. Shri Sharad Kumar Agarwal, Professor, IRISN Pune. Shri R.K. Agarwal, Chief Engineer, Track Machines, North Central Railway. Shri Prabhu Sankar, Director, Belfort Betty, Engineering and Technology Solutions, UK. And Shri KLVS Vishwanath Dham, Assistant Manager, Civil.
So ladies and gentlemen, we have the chairman, the co-chairman, and all the authors for the first technical session on stage. And now may I request the chairman of the first technical session, Shri Vishwesh Chaube, the General Manager of Northern Railway, to kindly take over.
Very good morning to all of you. I'm very happy to chair the first technical session of IPWE being held at Guwahati. And being the first session, I'm sure that the session will be very lively. Total we have 90 minutes before lunch, and we have to take out 20 minutes for question and answer. So net time for presentation is 70 minutes. So I'll request all the authors to restrict their presentation to 10 minutes each. There will be a bell after 8 minutes, and then you will have to conclude within 2 minutes. There will be, if anybody is having any question and answer, that you can note it down on a piece of paper available in the folder provided to all of you, and that can be given to the nearest hostess, who will give it to me, and then I'll pass it on to the authors. So the first paper is on the subject development of food plate inspection, GPS-based OMS and use of third-party trolley data for design tamping by Naveen Chopra and Ashish Bansal. Mr. Naveen Chopra can present the paper.
Respected Member Engineering Railway Board, Shri Gupta ji, the Chairman of the session, Shri
we can skip the
right, sir.
Salutation and we can straight away come to the...
From the Northern Railway, we have 3 topics which we are covering in this presentation. As Chairman has said, this is one of the food plate inspection. The app has been developed which is used in Northern Railway. Second is the GPS-based OMS, and the third is the third-party trolley data for design or tamping. This app which has been developed is based on Android application, mobile GPS, and the RDPS data which has been picked up by almost all the railways, that has been utilized for this application. Basically, the RDPS has been uploaded in the mobile, and the data used is almost like 13 MB. And on the 7 features we have developed on the application, which are the lurch, patrol one location, gang working, gateman not alert, rough running, and release track material. The bottom two are the toggle base. We can start the kilometer, we can note down the start and the end of the kilometer. Brief of this app is, it contains 5 modules: route selection, main interface, manual counter, report interface, and data report. Route selection, like on the Northern Railway, if we pick up in the drop down menu, we have number of routes. We can pick up any of the routes and then go to the next one. Main interface, it has 7 features as shown on the screen, like lurch, patrol one location, gang working, gateman, and rough running, and track monitoring. It has got a counter also. As we start the mobile application on the footplate, you simply have to press any of the button, as depending on the lurch, you just press the lurch location. If you find the patrol one location, you press the patrol one location. Similarly, if you are finding rough running kilometer, the start and the end application is there at the bottom one. Report which is getting generated is shown on the right side. We can select the route, we can select the date, and it can save the data in the software, in the sort module also. Data which is generated is in this form, which is shown on the right side of the screen. It shows the location, speed, and the nearest RDPS track features like kilometer post, punch and crossing, level crossing, whatever. Whatever we have loaded in the route tab, this all the feature will be shown in the report which is getting generated. I will just run for 10 seconds. Start. Video is not playing. The counter will keep on running at the number of times you attempt, like the last 7 location. So it's the actual, during the run we keep noting gangman location, gang working, toggle structure. These are the reports which are coming. The next is the GPS-based OMS which we are using on the Northern Railway. I will tell Ashish to cover these 2 small topics.
Thank you, sir. I will just brief on this GPS-based OMS. Though certain railways have done it, I will just brief it because we started it on Northern. Basically, it is a OMS device with GPS acquisition facility. It is provided with a tablet, and this RDPS data is loaded in the OMS. And the threshold value, minimum acceleration which it can measure is 0.1 G, and it is connected to the tablet via hotspot. And this program of the tab, this will capture the peaks above the threshold level and display the right index. And it has 5 interfaces. Some of the interfaces they are for recording, others are for report generation, calibration, etc. And then we can fill the details of the section and the maximum running speed and the maximum speed of the section. And this is the initial screen where we either choose the option for starting the recording or generating a report or calibrating. And this is the calibration screen which will show how to calibrate the OMS at the start of a particular run or during the run if we think that there is a problem in the run. And this is the mode selection. We will fill the various columns, run direction, leading and this TP counting section is electrified or not. And then we'll fill the sectional details and threshold values. And this is the recording interface. The screen on the left side, this displays the vertical peaks, and on the right side it is displaying the lateral peaks. And this is the demo. I'll just skip basically this demo. And since it is GPS based, it automatically takes the location from RDPS, and it does not require any specialized manpower. And the third part is the use of third-party trolley for design temping. Basically, in design mode, when we are working in the design mode, we need the track geometry. Either we have to take it manually with the help of total stations, or we can deploy the measuring run, which is facility available in the latest generation of machines. So that measuring run has to be done, and then the machine takes it automatically for working in the design mode. But the measuring run consumes time. Block time is very precious, so to basically optimize that, we can take the data in by the use of a third-party trolley, and then this can be directly fed to the ALC of the track machine, so that it can work in the design mode. This is a simple flowchart for the trolley, and all the trolleys, whether they are working on differential GPS or inertial measurement, they are first establishing reference points, and then they are doing the survey. And then a digital alignment of the track is generated, and this is fed into the ALC of the machine. That should be compatible. And then we can measure the post-temping data also to find out the efficacy of the track machine. And as already we have, I told, the 10% block time is basically used for data analysis, and 25% block time is wasted if we do the pre-run and post-run also. So these are the requirements for third-party measuring trolley. Basically, accuracy is the prime importance. It should have a post-data processor. Compatibility with the ALC should be there. Economics, simple operation, speed of movement, and robustness. There are three types of trolleys which are available in the market. First one is based on this inertial measurements. This is just like the TRC which we use, but less complex than a TRC. And it has high accuracy in local coordinates. Cost is also high. And another one is differential based, which has got a very high accuracy in geospace. Cost is also high, but accuracy is slightly questionable. And the third one is electromagnetic, which is based on the local GPS. So accuracy is not very good. Both types of trolleys, that is the differential GPS based trolley or inertial trolley, they are both basically they require operational expertise, and for this maintenance also expertise is needed. So if we save 20% of the block time with pre-recording using these trolleys, and our unit cost of the temper, if we work out every year, we are working out, it comes out to about 50,000 per kilometer. If we save 20% of the time, then the saving is about 10,000 per kilometer. So considering the expertise required in operation and maintenance of these trolleys, outsourcing of this measurement per kilometer is a suitable model. I'll just go through fast in this working principle. As I mentioned earlier, this is the same working principle as is being used on the TRC. It has got 3 gyroscopes, 3 accelerometers, and once the trolley is put on track, its location is recorded. And then these track parameters, various track parameters are recorded. And we had done a case study on this Delhi Shadra Shamli section, where a track was stamped with the help of the third-party trolley. And as you can see that there was an improvement of about 32% with the use of the data used by this third-party trolley, which justified its efficacy. Another trial which we did is we took 3 patches on a section and did the work by smoothing mode, and another patch we did the work by this measuring run, and third patch we did by this amper trolley measurement. These readings, they are slightly misplaced, but if you see this Embark, the track which was stamped with the help of this Embark system, this is comparable with that done with the help of this MR. This is the photograph of the trolley. This is small demo, I'll just give in brief only.